Many engineers are using AI completely wrong. And because of that, many companies are restricting AI usage. Not because AI is bad, not because AI doesn't work, but because engineers are doing like this. Production goes down, and engineer downloads huge log file that is around 50,000 or maybe 100,000 and then uploads everything into ChatGPT, Claude, or any other AI model which has a lot of information. For example, customer information, IP address, then sometimes internal host names. Then everyone is surprised when security teams start asking questions. Today, I am going to show you a different approach. By the end of this video, you will learn how to safely use AI on production logs, how to remove sensitive information automatically, how to dramatically reduce token usage, how to use a local AI model, how to investigate incidents faster, how to keep humans in control. And the best part is that you can take this project and implement it in your own environment. Of course, every company is different. You may need to adjust log formats, some policies, and AI models according to your requirements. This is not a toy prompt project. This is a practical DevOps project. Before we start, I have a small request. If you enjoy practical DevOps and AI projects like this, hit the like button. And if you want me to make this entire project public, including the code, architecture, setup instructions, and future episodes, leave a comment below. If this video gets at least 100 comments, I'll make the complete project available for everyone. Now let's build it from scratch. Everything is already prepared. If you can see, I'll try to write a tree command. We have multiple different files ready. I'm going to explain each and everything in detail. First, let's try to understand architecture before we start. I'm going to jump back to my board once again, and here let me write it down. So first we are going to check logs. This is how our workflow looks like. Followed by we are going to sanitize those logs. Then we have a pattern extractor, and then we are going to talk about the token optimization as well, and finally AI analysis, and one last step is human validation. So this is our flow today. We are going to check logs, sanitize those logs, we are going to extract patterns. Also, we are going to talk about the token optimization within this workflow. AI is almost at the end. Most tutorials start with AI. We start with engineering. That's the difference. And finally, we have human validation. All right, let's jump into the Visual Studio Code once again. So here, as I said, our project is ready. I'm going to start with generating log files. So I'm going to run Python 3 generate logs.py, press enter. If you can see, it generated logs raw application.log with 50,000 log lines. In a real company, this could be Kubernetes logs, or maybe Jenkins logs, Nginx logs, application logs. For this particular video, I'm generating realistic production style logs. But these logs actually contain the same information which we actually see during real incidents. So first I'm going to run a simple command. For example, wc-l logs followed by raw application.log. Press enter. We have seen already 50,000 log lines here, and also I wanted to show you by running this command 50,000 lines. Now we have 50,000 lines of logs as you have seen in the terminal. Now imagine it's 1:30 a.m. midnight, production is down, customers are reporting errors, management want updates from us. Would you manually go read these 50,000 lines? Probably not. And that's why AI becomes attractive for us. But before we involve AI, let's understand what we are actually dealing with. I'm going to jump back to my Visual Studio Code once again. So first, we are going to run a simple command once again. Here I'm going to clear my screen. Head -5 followed by logs raw application.log. Now look at this very carefully. If you look at here, I can see customer email details very clearly, customer.payment@example.org, followed by, and I can also see the IP address, and we have a API token as well. We have some request ID as well. This is exactly why security teams are nervous about AI. Many engineers like us see logs, AI sees data, but security teams sees risk. Now let's try to run tail-5 logs raw application.log. Now look at this particular information. Most engineers look at this and think, let me just copy this and paste it to any AI tool. But there are two problems here. So number one problem is security, and the second problem is cost. And this is where things get interesting. Let's talk about something almost nobody discusses it online when they create AI tutorials. That is tokens. Nothing but AI currency. Most AI demos online look amazing. Someone uploads a huge log file. AI will give you an answer, not an issue. Everyone says, wow, this is amazing. I uploaded the log file, I got my answer, that's it. No one thinks about how much data did we send? How much did it cost? Would our company actually allow this? Let's think about our example. So 50,000 lines of log file we generated. Imagine this in a real production environment. I already showed you these logs contain customer emails, service names, request information, session information. I mean, we have a lot of stuff here. Now we have several problems here once again. Number one here is cost, which I already discussed. AI models don't read files, right? They read tokens. The bigger the input, the more tokens you are going to consume. The more tokens you consume, the slower the response rate, and also the higher the cost. Now imagine a company processing incidents every day. Hundreds of engineers doing that. Thousands of investigations go on. Those costs add up very quickly. Now, we'll talk about one more problem. So, problem 2, which is noise. Most production incidents generate duplicate errors. I mean, if you are working in a production environment, definitely you are going to relate with whatever I'm talking here. You will see so many duplicate errors. You are going to see same timeout message multiple times, same exception messages, and also same connection failures again and again. Now think about this. Does AI need does AI need all of these duplicate lines of logs? AI needs only patterns. Problem number 3. Now let's talk about the problem number 3. Think about GDPR. Think about internal security policies, customer contracts, regulatory requirements. I mean, these are, let's say, very few problems. I'm trying to write it down here. Many companies explicitly prohibit uploading production data into external AI systems. Not because they hate AI, because they have responsibilities to customers whom they serve. Now let's talk about problem 4. This is a very huge problem. Context windows. I mean, many tools, many companies are, let's say, trying to solve this particular problem, but this is a huge problem. Even if the model supports huge context windows, I mean, some of the models are already doing that. Should we waste them on duplicate logs? What do you think? Let me know in the comments. I would probably say not. Good engineering is sending better information, not sending like more information to AI blindly. The goal is, how do I send better information to AI? That's exactly what we are building today, and we are going to solve this problem. Now let's jump back to our Visual Studio Code once again. So if you look at this particular screen, now I'm going to run a script which is python 3 sanitizer.py. I'm going to run this particular script, and also I will try to explain it. Don't worry about the script explanation. This is where real magic begins. We are not removing useful information. We are just trying to remove the sensitive information. Now let's try to run the command head-3 logs raw application.log. So this is our raw application.log file which we generated in the beginning, followed by I'm going to run the sanitized log now. So let me run this. So this is our sanitized application.log, and this is our raw application.log. Now let's look at the difference. So if you see, previously we had critical service auth API user details, let's say the email. In this particular sanitized log, I cannot see anything. I see user equal to email, IP is equal to IP, and token request ID. Everything is hidden. The IP is gone, the token is gone, and also the request ID is gone. Because AI doesn't care whether this particular email belongs to Arbaz or not. AI only needs to understand there was an email like this. That's a huge difference. Now, let's look at the actual code what we have in this particular file. It's very, very simple. If you can see, it's let's say only 35-36 lines of code. What exactly we are doing here? Number one, it will try to find the sensitive information, right? Followed by it will try to replace it with the placeholders. Okay, the placeholders which we saw in the output, email, IP, all of the details. Step 3 is nothing but we are trying to write a sanitized version of the logs. That's it. This is very, very simple, effective, and the practical use case I'm trying to show in this video. Now we are solving the second problem, which is noise. Press enter. So if you see top 5 patterns, production incidents are repetitive. The same error appears thousands of times. AI does not need to read every line, every copy, right? Now, this is already written to this particular file. I'm going to open that real quick. Cat reports incident summary.md. Now look at this. Imagine seeing database timeout, let's say multiple times, or you want to see this particular error message. The count was, let's say, 1678. It is better if we see something like this. Count, let's say 1678 for this particular service auth API, and I can see the details. This particular line was written multiple times, 1600 times. Followed by, we can see for another service, 1677 times, then 1643. The list goes on. Which one is more useful? Let me know in the comments. What do you think? Is this particular summary file is better, or pasting the whole raw log file to the AI model? For me, this looks way better than pasting the raw file, because this simple optimization alone can save enormous amounts of tokens. I'm going to show that as well. Just wait a minute. Now let's look at the pattern extractor.py file, what exactly it is trying to do. Again, this is a very, very, very simple file. We are trying to group patterns here. For example, I'm trying to give the details, input file, report directory, and the report file, and important levels here, error, critical, and warning. We are trying to remove the duplicate lines here, and also trying to extract some patterns. Followed by, we are trying to write this particular report into this incident summary.md file. Think of this particular file like log compression for AI. Instead of sending noise, we are just sending the signal. Now let's jump to my favorite section, Python 3. I'm going to run this script, token estimator.py. I'm going to run this now. Press enter. Now let's look at the output. This is very, very interesting, because this is where we measure the impact. Most AI tutorials which you see online will not discuss about this. Real engineers care about cost. Now let's compare this. Estimated tokens. This is raw application.log file. It has 50,000 lines. Estimated tokens 2439454. Then let's look at the sanitized application.log. It also has a lot of tokens. Then finally we have incident summary.md. It has 106 lines, estimated tokens 841. Now look at the difference. We try to reduce the amount of information that needs to be sent. This means we are going to send only 841 tokens. Here we have so many tokens and we compressed it almost to 841 tokens. I am going to copy this real quick and jump back here to my blackboard. Now, if you see, we are trying to reduce the summary to 99.97%. What does it mean exactly? That means we are going to get faster responses followed by lower costs, better accuracy, smaller context requirements. How many of you agree with this? Let me know in the comments, what do you think? Will this save your time, also the money to the organization? Let me know in the comments, what do you think? Now let's jump back to our next part, Ollama list. So I do have so many models right now. For this demo, I'm going to use Mistral model. So I'm going to run this script real quick. AI investigator.py. Press enter. If you see, this particular script is trying to send sanitized plus aggregated summary to local AI model. Now, if you remember the full flow, this is the first time AI enters the workflow. Notice how late that happens. AI is not step 1 in our full workflow. AI is at step 5. Now let's look at the response. We try to write the investigation report to this particular file. I'm going to open that real quick. Cat reports followed by AI investigation.md. Now let's go through what exactly AI is trying to tell here. Most likely, the root cause appears to be a high load on Postgres database, leading to connection timeouts and exhaustion of the connection pool for multiple services. It mentioned the multiple services here. This could be due to an increase in traffic or poor database performance. Evidence from logs. The logs show repeated messages indicating critical issues such as Postgres max connections reached, database connection timed out. Impacted systems. The primary impacted systems are Auth API, Checkout Service, Nginx Gateway, User Service. Recommended next steps. Check PostgreSQL logs for any errors or performance issues. Analyze database queries to identify slow running queries that might be causing the high load. Check if there is an increase in traffic that could be causing the load of the database. Investigate why background workers are failing. Monitor the response times of your service and identify any service that is consistently slow or returning 500 internal errors. Also, we have a confidence scores here, 80%. This score is subjective and based on the provided data, but the patterns of logs strongly suggest a database related issue. What human engineers must verify now? The human engineer must verify the current state of Postgres, including checking for high loads or slow queries, and investigate if there are any unusual traffic patterns that could be causing the increased load on the database. All right, now it is very clear according to the output. Now we are going to do a manual check once again. This is the step most AI demos are going to skip, which is verification, because I want evidence, because production systems deserve evidence, not assumptions. I can clearly see the evidence here. This looks fine. I'm going to run one more command now. grep connection pool exhausted log sanitized application.log. Now it clearly shows the error messages. It is not giving us assumptions. We have a proper direction. If AI tells me something, I want evidence, because production systems deserve evidence, not assumptions. AI gave us a direction. The engineer validates the results. That's how responsible AI adoption works. Now let's understand the AI investigator.py file, what exactly this particular file is doing. I'm going to briefly explain about this particular file as well. A lot of AI projects which you see online are over engineered, but the core idea is actually straightforward. The first thing we are doing here is loading the summarized incident report, not the raw logs or the sanitized logs which we generated, only the summarized patterns. This is a very important design decision because we already spent lot of time to reduce the noise. Now AI will receive only the most important information. The next step is prompt construction, and this is where many AI projects fail. People think, let's send some data to AI and see what happens. That is not engineering, that is gambling. Instead, we tell the model exactly what role it should play. In our case, we are saying senior site reliability engineer, followed by we are providing some important rules here. Do not assume facts, do not invent services, give a confidence score, provide next investigation steps, keep the response practical for a DevOps engineer. Also, we are asking the written format, most likely root cause, evidence from logs, impacted systems, recommended next commands, confidence score, what human engineers must verify. Notice something in this particular prompt, we are forcing the structure. Structured outputs are much easier to consume than blindly AI generated paragraphs. Especially during an incident, midnight, we want what exactly happened and what is affected. That's exactly what we are asking the model to provide. Third step is we are using Ollama here, local Mistral model. If you see Ollama run Mistral in our Python file, because I wanted to run it locally. Majority of the organizations don't want to send their data outside their company. I mean, there are different ways to host ChatGPT models or Cloud Code models locally, but in this case, I don't want to talk about that. If you are interested, you can try with other models. I would like to keep it simple. I'm running it locally on my computer. I have a GPU based computer. Also, we can save a lot of money if we are using local model, and also I don't need to worry about tokens if we are doing local models. The final step is taking the AI response and saving it into a report. This is another practical design choice. Most engineers only try to print output to the terminal, but in real environments we usually want artifacts, so that it is very easy for me to read, and also I can attach it to the incidents, for example, if I'm working on that, and it would be useful in future. I am not sure how many of you noticed from the beginning, the AI part is actually one of the smallest parts of the entire workflow. Most of the work happened before AI was involved. For example, we did sanitization, we did pattern extraction, we also did token reduction, we did some data preparation. That's where engineering creates value. AI is simply helping us interpret the information faster. That's why I keep saying most tutorials start with AI, we start with engineering. Today, we build something I believe is far more realistic than most AI demos online. We did not blindly upload log files. Also, we did not trust AI blindly. We built guardrails. We reduced token usage a lot. We protected sensitive information being sent to AI models. We kept humans in the loop across the workflow. If you are a DevOps engineer or platform engineer, SRE or cloud engineer, This is exactly the type of workflow I think we'll see inside real companies over the next few years. If you want the full project, remember the challenge: 100 comments below this particular video. If we reach 100 comments, I'll make the complete project public. And if enough people are interested, I'm going to continue this series and build AI incident triage assistant, AI Terraform reviewer, AI runbook assistant. Now, I want to hear from you in the comment section. Would your company allow AI to analyze production logs if those logs were sanitized first? Let me know in the comments. Thank you for watching and see you in the next video.